meeting is being recorded. Okay. So my video's on. You can hear me. Check, Mr. Green.
Yes, we are good. Can you hear me?
Yeah.
You're good.
All right. Excellent. I think we are ready to go.
I'll share my screen here in a minute.
It looks like we just have some folks coming in. Maybe give them a moment.
Oh, 27 people already. Let's see that down there. Cool, cool, cool. Might as well go ahead and share my screen. Couldn't find the share screen button, and it's highlighted in green very obviously. So.
Looking good, Dave. There's a couple blocks sitting on top of your Frizo. Yeah, right there on the right-hand side where your mouse is.
Best I can do right there.
Yep, you're good. We can see it.
Okay. All right, we're gonna wait at least 2 more minutes to get started. Just let everybody know.
Dave, are you going to use any of your new 3D printed flight controls for the new version of Microsoft Flight Simulator that's coming out?
Well, I would love to. So I don't have a computer that can run the new Flight Simulator 2024 that's coming out, so I'm super jealous. I was thinking about doing that on my Xbox, but then I really don't know how you interface the stuff that I build into an Xbox. Maybe there's a way. I just don't know how to do that. One more minute.
While we're waiting, Dave, maybe for all that are joined, maybe if you could just raise your hand if you've done any sort of 3D printing before, or if this is a first time. Raise your hand if you've done 3D printing or have one at home.
Oh, wow. Okay.
Robin.
Hold on a minute. Everybody's raising their hand.
Yeah, this is intro. That's all right. Maybe you'll learn.
You're gonna learn
here. Great.
4 or 5 of those 3D printers. So yeah.
Yeah.
Excellent.
Well, yeah, if you've done 3D printing before, you're still going to learn something today. That's fine. So it is 12:03. We got 40 people on the call. I guess we can go ahead and jump in because we only have, I don't know how long this session is supposed to last. But I was going to try to cram it all in 45 minutes or so. So we will jump right in. And today what we're going to be doing is an introduction to 3D printing. So what I wanted to do first before we get started is introduce myself and then let Mr. Tom Green introduce himself. My name is Dave Mathis. I'm one of the senior cloud architect engineers here at Fulcrum. Been here for 8.5 years almost. And I'm also the team lead for the cloud team. So if you guys have any need for Azure services or AWS services, just let us know. We also do a lot of security assessments against M365 environments and that kind of stuff. From a 3D printing perspective, my background is that I have about 4 years experience with 3D printing, and it coincides exactly with the release of Microsoft Flight Simulator 2020. So we'll talk about that in a minute. So Mr. Green, if you want to intro yourself.
Thanks, Dave. Tom Green. I'm a senior security architect here at Fulcrum. Was recently kind of brought over with the Fulcrum team. We were over on the Talus Solution side, which is our identity and access kind of division, if you will. I'm the managed service lead over there, primarily dealing with the access management. And from a 3D printing, kind of same area, about 4 years or so. I had a want to. I really love the old jarts, the old style jarts, and I kept finding the flights on the jarts were breaking, and thought maybe this would be a good way to learn a new skill and put some practicality to it, so I could continue to use my jarts in the backyard. So
But,
back over to you, Dave.
well, I thought those were illegal, first of
Well,
all.
they're illegal to sell, Dave. They're not illegal to use.
Okay. All right. So I guess kind of the way I wanted to start with this today was talk a lot about kind of the the why. Like, why does anybody get into 3D printing? I think everybody has sort of a different idea of why they would do it, why they would want to do it. Like Mr. Green mentioned, he needed to fix his jarts. For me, I never thought about 3D printing or wanted to do it until Microsoft Flight Simulator came out in 2020 with a new version. And I started flying that, and it brought back all my love for, flying and simulation, and also my desire to start building flight panels, like real world flight panels that would interact with the game using like the SimConnect DLL. So before that, I'd never 3D printed before. And I thought, man, this maybe is something that I could do. And so kind of here is from some of my stuff that I've printed. Over on the left is what I'm trying to reproduce. This is a Garmin G1000. It's primarily used in a Cessna 172. And you can see all of the knobs and buttons and switches. So I've built 2 of these, and I can't show them today, but I got some of the parts broken down so you can kind of see where I was headed. So the very first thing that I ever 3D printed in my life was a knob. And that's some of those in the middle picture there. Most people print something a little more exciting than that. Mine was knobs from my G1000. I had to teach myself Fusion 360 and how to, basically design things in 3D and then export that out and then do 3D printing with it. And then over on the right is sort of a breakdown of the left panel. You can see that where there's a circuit board in there. That is a custom printed circuit board. We're going to talk about that more today at 4 o'clock in that session, how you do your own custom printed circuit boards. And so then you can see the frame, and then you can see all of the buttons in there. Those are all 3D printed. And then the lettering is actually done with a 100-watt CO2 laser that we use to etch out clear acrylic plastic. But anyways, that was how I got started with 3D printing. And just so, like, if any of you here haven't really done a lot of 3D printing and don't know how to get started, keep in mind that I started 4 years ago. When I ordered my printer, I had no idea at all how to use it. I didn't know what a slicer was. I ordered my first 3D printer, and I thought I could plug it in with a USB cable and install a driver or something. No clue. And so I went from that to being able to do things like the G1000 pretty quickly. So whatever your need is or whatever your thoughts are, it can be possible with 3D printer. But today we were going to cover this from kind of the perspective of someone who has not 3D printed before, doesn't know much about 3D printing, wants to get into it, but doesn't know where to start. And then when you do try to get into it, there's just so much out there and it's confusing. And literally these printers come with no instructions. And so kind of how do you do it? How do you get started? Where do you go? And so what we are going to try to do today is talk about 3D printing, but then start to focus the conversation down into what we would recommend a beginner do to get started. So with that, we are going to talk about different types of 3D printing. We'll talk about some of the common brands of printers that are out there. We'll talk about the 3 different methods that we're going to deep dive into today. Some of that's going to be SLA, SLS, FDM. So we're going to talk about all those acronyms and what they are. Hold on a second. We're going to talk about top features of a good FDM 3D printer. Hold on a second. If there's a way I can minimize this junk at the top. We'll talk about the features of a low end kind of entry level 3D printer and then a very high end 3D printer. And kind of the idea there is that if you start shopping around for your own, you kind of know what features you're going to be looking for. And then some online resources. So if you don't want to spend a year of your life learning Fusion 360, you don't have to. There's ways that you can go and download things already designed for you and you can print them. And then we'll talk a little bit about slicing and a slicer. And then we'll kind of finish that conversation up today with 3 different 3D printers that we feel like would be good for people who are just kind of getting started. So with that said, we're just going to jump right in. This is types of 3D printing. So this is kind of a quick history of 3D printing and how it got started. So over on the left, you can see this is called SLA, or stereolithography, also known as resin printing. So a lot of times you'll hear people refer to it as resin printing. The official name is stereolithography, but everybody calls that SLA. This is the one where they use resin. They shine ultraviolet light into it. We're going to deep dive into each 3 of these, so I'm just going to hit these very fast. This was actually created way back in 1986. There's actually a little controversy over there. I think it was created before that, but the guy who originally created it didn't file a patent. So this guy came along, Chuck Hull, he filed the patent for it. So he is officially considered the inventor of 3D printing. So he created the SLA format, but he also created, down there you can see the STL format. So this was, I don't know, almost 40 years ago. And we still use at least the extension STL today. So if you're going to go download something off the internet to 3D print, chances are it's going to be in the STL format. So he's the guy that actually created that. And then in 1988, this came along. It's called SLS, which is called stands for Selective Laser Sintering. This was in 1988. UT student created this. And basically it uses like a powder and it uses lasers to, like center the powder into a shape. And I got some slides on that here in a minute. And then that was probably one of the top methods of 3D printing in the world until FDM came along. And FDM, I think if you look at that on the right, that is probably what 99% of people who think about 3D printing, that is what they think about. Maybe you didn't know it was called FDM. Maybe you didn't know that stood for fused deposition modeling, but that is probably what you thought of and considered to be 3D printing. And this is on the right. This is the one that is most commonly used in the house for very specific reasons. And we'll get into that. So that's the different types. So what we want to do now is I'm just going to jump into each one of these. We're going to do a shallow dive into SLS just to talk about it. And then we're going to deep dive into SLA and FDM. So with that said, let's talk about SLS. Oh, no, I do want to show one thing. So FDM was created in 1989. This guy, Scott Crump, he filed for the patent way back in 1989. It took a few years, and he got the patent for it in 1992. So this is a picture from his original patent back from those days. And I looked at this, and you can kind of see, if you look at it, the beginning of what looks like the modern day 3D printer. You can see the extruder in there and the stuff coming out onto a build plate. But what I thought was humorous about this picture was the computer. That's kind of looks almost exactly like the computer I had growing up as a kid. So it brought back some good memories. Okay, so with that, let's do this. Let's jump now into SLS, selective laser sintering. And so I hate to get all formal and everything, but basically this is an additive manufacturing technology that uses high-powered laser to sinter small particles of a polymer powder into a solid structure based on your 3D model. Well, okay, so basically what it is that you have this container, and inside the container, there's an arm, and this little picture is supposed to move, but oh well. What happens is this arm moves back and forth across the container at each layer, and it lays down a very fine layer of powder, and then the laser shoots from above and basically sinters it or melts it or burns it or whatever, and makes it solid, and that adheres it to the layer below it. And so kind of what's interesting about this is that in this container, you can have multiple things all being printed at once. So you can print lots of things all at the same time. And then you can even print things almost in three-dimensional space, because you can lay down a few layers of powder and then start printing another object on top of that. So at the end, you end up with this container it's full of powder, and then buried inside down inside the powder is each of the things that were 3D printed. And then they pull all that out, they clean those off, and then they take all the powder that's left over and they suck it all back up into the bin and reuse it. So there's some pros to SLS. One of the big pros is that you can get very highly detailed parts, and they're very strong parts. But of course, the con here is that you really can't do this at home because it's very expensive. So you could do this at home, assuming that you wanted to buy a $20,000 to $30,000 SLS printer. So most people don't do that, and so these are more for commercial use. I talk about it here today because it is, one of the top ways that they do 3D printing, and it is actually accessible to you if you wanted to use this method. I showed you earlier some pictures of the frame for my G1000. Those were printed with SLS because my use case was I needed very detailed parts, but I also needed them to be strong, and I couldn't do that at home. But when we say expensive, each one of those parts of my frame is about $20 each. So this is not something you do very often. Typically what you would do is you prototype your part with maybe a FDM printer or SLA, and then once you got it just right the way you want, then you could send it to a manufacturer to have it made. So we'll talk about that a little bit later. So that is SLS. And now we'll get into SLA, which is stereolithography or resin. And this one is one that you can do at home. You can go buy, off the shelf, 3D SLA printers. I have an example of one over here on the left. That's actually pretty similar to the one I have. And then the way it works, we'll start here in the middle of the screen, and we'll talk about the way that SLA works. Is that you have your printer, and you have the base of the printer, and then you have the shield that goes around it. And of course, in this, to the left, you can see that the shield is it's kind of a yellowish color. That is because it allows you to see through it and watch your item being printed, but at the same time, it blocks the UV rays from going in there and causing the resin to harden. So you have down in the base, you've got the mirror and the laser that shoots up through the base, and the base has it's clear sheet of glass that the resin tank sits on. Some people call it the resin tank. I call it the vat, my resin vat. And you can see kind of an example of that over on the right, where we have the resin, and then you see him pouring the resin into the vat. Let's see if I can go to the next slide real quick. So on the left, you see this is kind of a breakdown of what the vat looks like. It's got the two pieces where you insert the plastic sheet, and you screw that together, and then you screw that into the actual vat itself, and you end up with a clear bottom that allows the UV light to shine through from the laser below. And I've got a picture on the right just to show what happens when you accidentally punch a hole in the bottom of your resin vat. This isn't mine, but I put this picture in here because I did that exact same thing to mine. A bunch of resin came out while I was printing. About 4,000 layers later, it turned into a solid mess I couldn't clean up, so I had to replace my LED screen. So taking a look back here on this is the way it works. You can kind of see in each of these two models on the left, you can see that there's this thing, it's called the build plate. And what it does is in an SLA printer, that build plate only moves in the Z-axis. So it only moves up and down. So what it will do is it will go down all the way into the very bottom of the vat, and then the UV light shines from the bottom and hardens whatever the pattern is for that layer. And then the build plate pulls up, resin flows back up underneath, the build plate goes back down, and then it shines the LED light again with the UV light, and then it pulls up, lets resin flow back in, and just does that over and over and over. So in an SLA printing, you can look at that and you can see that they actually print upside down. And so that's how that works. And so kind of the original models of this use the mirror and the lasers. That's how they did it. The more recent versions, more modern versions of this use LED screens that are specifically designed just to put out UV light. And we are now in the world where you can do 4K quality, 6K, 8K quality, and you can end up with some extremely highly detailed parts. So I think I got an example here. We got the Hulk. And if you just look at this, there's a lot of things you can notice about this SLA print. First of all, you don't see any print lines, which is great. That's one of the problems with 3D printing, is sometimes the quality of it is affected by the print lines. Here, you don't see any of that. And if you really look, you can see details down to like the veins in the arm. You can see individual teeth. You can see like on his fingernail over here, some like cracks in his fingernail. So extremely highly detailed objects that you can print with SLA. So you might say, okay, well, from a beginner point of view, and I don't know much about 3D printing, I want to get started. Why would I not want to do SLA if I can get such high quality? Well, that's because there are a lot of cons to it. The number one con probably being the fact that the resin is toxic. And so you can't touch this stuff. You have to wear gloves. You have to have safety goggles. You're supposed to wear a mask. You should only print in a room that has really good ventilation to it. So so if you have like kids or pets or whatever, you have to be very careful with this method to make sure that no one else is exposed. So that's obviously one of the cons. The parts can be a little brittle because it's a resin that you're hardening with UV light. They're not going to be nearly as strong as something that you can 3D print with SLS or FDM. And then, of course, it also requires a lot more equipment for you to have than traditional FDM printing. And so let's take a look at what that is. So you have to have some more pieces and parts. And so the first thing that you have to have and use is a UV, a wash station. So as you can imagine, as that build plate goes down into the resin and it pulls up, a lot of the resin is not being hardened, and so it is adhering to your print as it comes out. And so when it comes out and it's finished, it's completely covered in toxic resin, right? So you really can't touch it. So you have to wash it in something like this, like a wash station. And what it does is typically there'll be a little blade down at the bottom that swirls, creates a vortex, and it swirls the cleaning solution around your model. And that cleaning solution is going to be isopropyl alcohol, probably 90 to 92% isopropyl alcohol. There is some resins that are water washable, but for the most part, you have to use isopropyl alcohol to wash them. But kind of an interesting fact is you don't have to go buy any of this professional level stuff like the wash station and the UV curing station. You can build your own. So you can see an example down there at the bottom left. That's somebody that literally just took a tub, cut a hole in it, put a little motor in there, and made his own UV workstation. And then the other thing you have to have on the right is this thing. It's a UV curing station. So not only do the parts come out covered in toxic resin, Once you clean all that off, they still haven't completely cured. They don't completely cure these things as they print because otherwise it would stick to the bed and then you would have a failed print job. So you expose it to the light just enough to get it to harden so that it can pull off of the bed and let more resin flow underneath. And then once you've washed it, you have to finish curing it. And that's what this thing on the right is doing. That's a professional version of that where it's got like the UV light. It's got the yellow dome over it, and it also has a little turntable. You can put your object on there and it'll spin around until it's cured. I chose not to buy one of those. I did the thing on the lower right. I went to Home Depot, bought a, paint can, put some of that silver reflective tape in it, bought some UV LEDs off of, Amazon, and there you go. I built my own little curing station. So as you can see, we were talking about how we wanted to kind of help direct you in a certain way if you've never really 3D printed and don't know which way to go. We talked about how SLS is not really accessible to you at home. SLA you could do, but from a beginner point of view, it's really not the way to go because of the fact that it's got toxic chemicals and there's a lot more to doing it. You have to have much more equipment to do it. So really, if you're out there and you're just trying to get started, probably the best way to go is going to be this method, FDM. I'm going to stop and let Mr. Tom Green jump in and talk about FDM printing.
All right, thanks, Dave. I did see a question come in that Robin, did you want to direct that answer to that right now, or did you want to follow up with that
we
later?
can touch on that. I think, Spencer, you had indicated water and plant-based resins are becoming more prevalent. That's absolutely true. I think some of the actual, if you do finite element analysis for some of those filament types or those resin types, they're not quite as hardy, but certainly a lot safer to handle.
Yeah. All right. Thanks,
Hey,
Robin.
can I jump in real quick
Go ahead, Dave. Yeah, absolutely.
Okay, I forgot to mention something at the beginning. I want to mention it before people drop off or whatever. So we are doing a giveaway of a 3D printer, really good one. I think it's the Bamboo P1S, which is fantastic. We're actually going to see that one here in a minute. I did want to mention that. And then the giveaway is going to be handled tomorrow afternoon at the closeout session. So for everyone that attended this session, your name's going to be put into a big wheel of some sort that are going to spin, and somebody's going to win a printer. So I just want to say that before I forgot. I forgot to mention that at the beginning. So sorry about that, Tom. You jump back in.
No, that's quite all right. And I know it's probably against the rules, but Dave and I are probably also hoping that we get entered for the Bamboo P1S too. So, all right, sounds good. Well, thanks for that handoff, Dave. Yeah, the FDM, obviously we've gone over the fused deposition modeling. It's really the simplest technology in 3D printing. In short, you're pushing a piece of plastic string into a very hot area, which melts that, and the head on the printer moves around, or potentially the bed of the printer moves around, depending on what type of printer you have. Here in the screenshot, we're looking at a Creality Ender 3 Pro. These are very popular, globally renowned bestsellers due to its very low entry price and the capability to be swapped out and modded, the different parts within these. Though there are a lot of different types of printers, they're all generally sharing the same type of part list. And we can go through these here. Outside here, the frame bit, it creates a rigid environment for the rest of the components to work in. Having that printer be extremely rigid and, more importantly, square is crucial for prints to turn out the way you want them to. Over on the back on this one, we see a power supply. Pretty obvious what this does, but to supply power to the device. The display screen here, usually there's a way to interface with the printers directly. This gives you statistics about the hot end temperature, the bed temperature, fan speeds, overall progress of the print, and allows you to go through different menuing systems generally to make adjustments to that. Oftentimes there'll be some presets to say, okay, I'm going to be printing PLA, and have a stored preset where it's going to warm your bed to a certain temperature and warm your hot end to a certain temperature. Over on the other side, you'll see that there's an area for the motherboard that's somewhere on the Ender 3. It just happens to be over there. The motherboard carries the stepper motor drivers as well. Those parts can be replaced. Some of them are quite noisy just based on the electrical that goes through them. But these drivers move each stepper motor in the X, Y, and Z. So there's typically at least one driver per direction. And that's actually a good point here. We don't see this on the actual printer itself, but there is a motor for each direction in this. And being a stepper motor, it turns, it knows what a 360 is, and the resolution per motor, it knows to turn specifically the right amount in order to travel a certain distance. So the print bed here is where the model is going to be created. The print bed, based on the different model of printer that you select, they do come in many different sizes. The one here is shown with a flexible magnetic print bed as well. There's like an overlay that goes on top of that. That allows for the model to be removed pretty easily after the printer is done printing the part itself and the part has cooled. The print bed can also be made of many different types of things. Pretty common ones are glass, spring steel, PEI as well, which could be textured or smoothed, or polypropylene, excuse me. And the print bed obviously is where the majority of this happens. And the real important part here when you're getting going with 3D printing is really understanding how to get that first layer of plastic to stick to your bed. Usually it's called kind of like an elephant's foot, where you want a nice squish of that first layer to really spread it out and get it the most surface area you can to stick to that bed. So many people will use adhesive aids to that too. Many things. Dave, I think, uses glue sticks, for instance. I use hairspray, Aquanet. Been great for me. I do hairspray over glass. It's great. Some people do painting tape. So again, just based on the printer quality and also just your environment in general, will lead you down the right path of getting that first layer to stick the best you can. So, but ensuring that is pretty important. So, should also set a note here to mention, if it doesn't stick, it becomes a really big mess, as though those people that have there it is, have done 3D printing before have probably seen this blob at some point in their life. So but we'll touch on those a little bit later. The business part of the printer, I guess we would call it a nozzle here, usually attached to a hot end as well. But that is where the hot mass comes out, basically. So that string, the filament, gets pushed through the extruder and down into that area. And the extruders usually come in two classes. There's a demarcation in the way the filament is fed into that hot end. One's called a Bowden tube, excuse me, and that's what we're seeing here with the Ender 3 Pro. You can see above that there's a tube. The extruder pushes the filament through that tube into the hot end, and there's also a direct drive for the printers, and this type pushes the filament directly into the hot end. Each of them are pros and cons. Just understand that there are two different types. Generally speaking, the direct drive is going to give you a better print, as it doesn't have to retract a whole bunch of filament each time it needs to stop pushing filament out. So after that filament gets into the hot end, melts, it gets sent through that nozzle. The nozzles in general are made of brass. It's a rather durable metal, as we know. Although depending on the filament that you use, how much you print. Those nozzles do need replacing from time to time as well. And the nozzles do come in different sizes. 0.4 millimeter is generally a standard. You can get much higher resolution prints from your FDM printer using a smaller nozzle. If rapid prototyping is more what you need to do, don't really care what it looks like, so long as it's functional, you can also step that nozzle size up. And then you also see there's a cooling fan here that aids in producing overhangs and bridging. An overhang is where the printer is printing partially over the air, but also has a way to attach to the last layer. And bridging is where it is trying to literally print over thin air with no supports underneath it. So should that need to happen, you're obviously going to tell the printer go slow. We're going to ramp that fan speed up. Depending on the material type you're using, adjusting that fan temperature. And slicers are generally very good at this if you tell them what you're printing, and it understands how to adjust for those as necessary. And we'll talk more about the filaments here just coming up. But again, if that fan were to go out during your print or malfunction in some capacity, you might start seeing some of those blobs, that big yellow blob like we saw. So if we want to move on to talking about some of those different filament types then, Dave.
Yeah, so he mentioned filament a lot. And so I think when you get into FDM printing, like I said, what we're trying to do today is kind of help remove some of the clutter and where do you start if you're a beginner. And so you hear a lot about filaments, and if you go to Amazon and search for FDM filaments, there's hundreds of choices. And so I thought it would be important that we talk about, what is filament and what's it made from, and why would you pick one over the other, and what's a good starting filament. So the first one that you'll see is PLA. When I got started in 3D printing, I thought that stood for plastic, because I thought it was plastic. Well, it turns out that's not at all what it is. It's polylactic acid. And it's derived from plant proteins like cornstarch, sugarcane. So it's made from completely biodegradable materials, and that's why I like it, because I can throw my 3D prints away, knowing that they'll biodegrade in a landfill. I think I didn't mention on the SLA piece, you've washed all that resin into that isopropyl alcohol, that becomes a toxic substance. You're not actually supposed to dump that down your drain. So another con to SLA. But anyways, PLA is biodegradable, and you get tons of choices now with colors. Got a picture over there of just some of the colors that you can get. When you buy a filament, you always buy it on a spool like this, and you just kind of choose the color that you want. And so what's good about PLA is it's extremely available. It's cheap. It's really pretty good for prototyping. It's fairly durable, fairly strong. And so it's really just a good basic all around material to use. Hint, hint, if you're new to 3D printing, PLA is pretty much the way to go. But there are other kinds that are out there.
Can I just interrupt real quick,
Yeah,
Dave?
man.
You've got a picture right there of the wood filament as well.
Yeah.
I've used that quite a bit myself. It is PLA with basically sawdust that's been injected into it. So when you're done with the part, it actually allows you to sand it. It also allows you to stain it, and it accepts paint incredibly well.
Oh, yeah.
So I've found that if I don't need rigidity, if I want it to just really look nice when I'm done, wood filament has been like a really big go-to for me. And it's kind of the same price basically as your standard filament, give or take a buck or two for a spool. But it's a wonderful product. So yeah.
I saw a guy who took the wood filament and he programmed his printer to go different temperatures at different layers.
Burn it a little bit. Yeah.
And burn a little bit. He actually got kind of a nice wood look to it, and he sanded that and stained it. Looked really, really good. He was making bowls on his 3D printer. I thought it was really kind of a neat idea. So the next kind is the ABS, which I don't know, acrylonitrile, butadiene, styrene. I don't know.
ABS.
So this, yeah, we'll just call it ABS. It's very tough, very durable, corrosive resistant. So if you're trying to print something that you're going to use maybe to attach to your vacuum cleaner, like maybe you lost the nozzle and you know the little thing that goes on the end, you could just print another one, and you would want to use a material that's very tough and durable for that. PLA wouldn't be a good choice, but ABS would. There's PETG or PTG. This is very flexible and very strong. This is basically the same stuff they make like Coke bottles out of. And so you can imagine Coke bottles are very strong, but yet flexible at the same time. So you can get that material. And then ASA is very rigid, very durable, but also weather resistant. So if you're going to be printing something that's going to be used outdoors, you would choose ASA. But just some of the other things to take note nowadays, there's so many choices in what you can pick. You can get metal infused, which is really just like, it's kind of like the wood one where you can, it's metal that's been kind of placed into your PLA. So you kind of get the look and feel of metal, but obviously not the strength of metal. But over there on the left, you can see that's an actual metal part that was 3D printed. So you can print in metal now with one caveat. You do your print, and then you have to send the object into the manufacturer to have them center it for you, and then they return it back to you, and it would look something like that. So that sounds crazy. Like, why would you want to do that? Well, because that process is actually easier than having a manufacturer like CNC route the thing for you. So if you're just trying to prototype something in metal, that's an option now. And obviously carbon fiber, nylon, and more all the time, different choices. Like I said, there's so many choices. It's hard to pick which one you want. But from a beginner level perspective, you know, I would go with PLA. And I don't really have a preference on brand or anything. Typically, you go to Amazon, search for PLA, look for the one that's got the highest reviews. I guess the one advice I would give is that once you've picked a brand of PLA, kind of stick with it, because all different manufacturers, you'll just notice to have different melting points. And so you'll print just fine with one brand, and then you'll try a new brand, and it just totally ends up looking like that. And so really, once you get your printer set up the way you want for that PLA, I've always found it's best to stick with that brand.
I think that's a really good point as well, Dave. We'll get into slicing a little bit later.
Yep.
But all those things that he's talking about are very important to that, because you're telling the software when it creates the G-code file to say, you know, I need the temperature to be at this. And if you're not keeping up, understanding what temperature that PLA that you're printing with or other material that you're printing with, it's going to lead to disasters. And we're looking at one right here. I think, again, for those that raised their hand, you probably saw, you probably have seen this before.
Oh, yeah.
I wanted to go back. Somebody did say ABS is also more UV and heat resilient.
Okay.
Yeah, I think so. And also ABS as well. You guys might know ABS. Lego is made of ABS. So one thing that it is not, since it is petrol based as well, it's less recyclable. And it also is more common to shade variations. So just going back to this, yeah, we're not looking at the printer trying to, you know, print a plate of spaghetti here. What we're looking at is something that went entirely wrong. Should you go down the path of 3D printing, you are definitely going to run into this at least once. It's a learning curve. Things happen. Hopefully you can catch it before it gets this far, but this is the failed print. No matter how good you are at this, eventually, again, like I said, this will happen. Sometimes it happens to the best. I don't want to say like us. I can't say I'm the best of us, but it certainly does happen from time to time.
Well, this is what happens when you start your job at night before you go to bed and you wake up, and
Yeah.
that's what you get.
Instead of the time you're sitting there waiting for it to get through 10 layers, right? That's
Yeah, right.
just when you leave it. It knows, the printer knows, by the way, they always do. This probably was something like the first layer let go. We had talked about that earlier, where that first layer you want to get is actually as squished out as possible to get the most surface area to grip onto that build plate. Because otherwise, if things start shifting around, this is what happens. If it does let go, the model starts to move around on the print bed itself. The print head, it's running through a set of instructions on where to be in X, Y, and Z. It doesn't know if that print is still where it was supposed to be or not. And all of a sudden, it's printing into thin air. You got globs. Uh, those who have done this, cleaning out a jammed up print head and nozzle is not a fun thing because it just starts oozing out and building up on that nozzle, and you get quite a mess. And it's not fun to clean out, and sometimes even just replacing the nozzles the best way to go.
Yep.
Another way that these prints can catastrophically fail is layer delamination during the print process. This generally was going to happen on open printers like the Creality we saw, where it doesn't have an enclosure or a shroud or anything that you've built around it.
Take a look at that.
Yeah, and that's a great example that you've got right there showing on the screen. With the heat loss that is experienced, some of these parts the part may not be cooling or cooling too rapidly and not allowing the fusing of the layers themselves to occur properly. So if that happens, one of the layers could delaminate, crack, and all of a sudden you're back in that same area where part of the print is wobbling around while it's trying to print. It's trying to print into thin air, and you got your globs again. So understanding what went wrong is always, the key. That's kind of what it is in here in technology land, right? So with understanding that, and you become smarter and better adjusting with your printer as well. So it's kind of a learning curve with your specific printer as well. Each one's a little more temperamental than the next, and everyone's is a little bit different. So the newer printers that Dave's got on the screen here, like on the right, the Bamboo, they have better failure sensing to mitigate these types of things. But there's also software that is out on the market that's an open source project called Octopi, which is meant to be installed to a very low powered Raspberry Pi device. And there are some plugins for it that if you focus a webcam on, that has some built-in smart algorithms to say, this doesn't look right. I'm going to go ahead and shut down the print job at this point. So we can talk about a little bit more about Octopi a little bit later if you want to, but it's a great way to augment some of the less featured printers, I guess you could say. We'll get into that a little bit on the next slide here. So we'll jump over that then, I guess, right away here.
Sure.
Yeah. Oh, we're on the next slide still.
Yes, sir.
Yeah, I'm not looking at what you actually got up. So with the Creality, again, we're just kind of picking on this one. It's the one that Dave has. It's one that I have. I don't know, Robin, if you got one, or Randall's.
Got two of them. Yes.
Yeah, two of them. Yeah, a lot of people have them in just build farms. So if they maybe have like an Etsy business where they're just punching out parts for people that don't want to do 3D printing themselves and just buy something, it's a pretty heavily leaned upon printer. So. But from the budget end of the bit, it's a very good one. Out of the box, it's a fully capable printer. Requires more understanding of 3D printing, and if you're someone that wants to spend the time to get things set up properly, I mean, it comes entirely disassembled. It is a flat box. Think IKEA. You are putting the screws and screwdriver together and getting this thing get set up. There are lots of not great things about this printer, as I think I can explain, Dave can explain, or Robin can explain, but they can be overcome with either additional parts or replacements of certain parts. But the modification of the printer does start to add up, and it makes you think, should I have just gone with something better in the first place? So depending on the type of person you are and your budget for driving yourself insane potentially, or just, you know, if you really want to get into the meat of it and tinker with it, it's a good place to start. But excuse me. One of the real important things we talked about before was getting that first layer down. With a budget printer, you're generally not going to have any sort of assistance in making sure that your bed is level. That is crucial. If your gantry, in this case, on the Ender 3 is, you know, it's horizontal. If that is entirely true square, it is going to float that print head square across the bed. So if that bed is not entirely level, in one corner it may completely miss the bed, and in the other corner maybe digging into the bed. And in that case, you're not going to get a very good first layer, and subsequently the rest of the print is not going to turn out very well, because you're likely going to just break free from the print bed and away the part goes. One thing you can do to overcome that on a budget printer is to install a mod to it. I have one on command called the BL Touch. What I did is when I have the printer go out and start printing, it probes the print bed in 25 different areas to say, from my 0 point, this area is X, you know, -2 millimeters, and this one is +6. So it levels the bed in its brain, basically, to say, if I'm going over this area, I need to raise and lower the z-axis a little bit to compensate for the fact that this bed is not flat. In your higher end printers, I'm not going to steal Dave's thunder, but that generally is not the case. They will have something in there like that right out of the box, and maintain that bed level much better. So the budget printer, like the Creality, the Ender 3 Pro, bed sizes are generally a little bit smaller. You know, they can come as tiny as you know, a coaster. You know, but the Creality has a decent sized print bed, but it does have a limiting factor of how much can be produced. You notice with this type of printer as well, since it is traveling from the bed upwards, this is one where the head goes up in the z-axis as opposed to the bed going in the z-axis. The print piece height can also be restricted. Obviously, in an enclosed one like we're showing here in the Bamboo, that is still something to consider. However, generally the higher end ones are going to have just a bigger build volume in general. So with these as well, you're going to find it's got a single extruder. It's got a single hot end. So you're limiting yourself generally to being able to print within a single type of filament per print, or injecting a manual process in where you are pausing the print job, swapping out your filament, purging the print line, and then resuming your print should you want to swap colors through that. Your higher end ones, you're going to find do have multiple extruders, multiple different hot ends, or ways to deal with purge blocks as well. So maybe Dave can go through that in a bit. A limiting factor to this too, SneakerNet. It's kind of floppy disk days if you think about it. Out of the box, this thing has an SD card reader. You load up your G code, bring it to the printer, plug your SD card directly into the printer, and then through that menuing system, select the print job that you want. As I mentioned, Octopi does have a capability to overcome that in most of these cases, where you plug the Pi directly into the printer, and it can do the interfacing through serial with the printer itself. So then you can wirelessly send it print jobs, monitor print jobs, and interact with it wirelessly as well. So there's some additional capabilities to that as well. Let's see what else we got here. Open frame. Yeah, we talked about that a little bit. Oh,
Yeah, we got to speed up. We only got like 5 minutes left. So we got.
Oh, good God. Yeah. Well, why don't we just zip past this, Dave? Why don't we,
yeah. So as you can see, there's the left on and the right, we're just comparing budget versus high end. Really just so as you're out shopping for a printer, you'll know what kind of features you need to look for. Probably the most two important, just to kind of finish this up, is going to be the self-leveling is a really great thing to have. And then the multicolor, and then the 0.2 millimeter layer height is really going to let you have a lot more quality in your print. So that's as you're out shopping, you really do get what you pay for. You don't have to get the $850 one. You can get somewhere in the middle. We're going to show that here in just a minute. But I do want to just kind of give some examples of some different prints. It's the exact same print printed 3 different ways. So we talked about like, why would you pick one over the other? So FDM, you can see, has all of the layer lines, whereas SLA is completely smooth. So if depending on what your requirements are, you may choose SLA because you need that. But if you don't want to get into SLA but need the smoothness with the toughness, maybe you could just have it manufactured and do the SLS. So there's a lot of variation in what the prints look like when they're done and why you would pick one over the other. But if you don't care about seeing the layer lines, you're just prototyping, then FDM is a great way to go. Let's see, we got to get into common brands. I have this in here as a slide, just because if you're out searching, there's tons of brands out there. And if you're new, you don't know what's a Ford and what's a, Porsche versus what's a, Maserati. These are all really good brands to get and use. So if you're out there searching and shopping for a brand, you can't go wrong with probably any one of these. I've got the Anycubic for resin. I've got the Creality for my FDM printing. But Bamboo Lab is really coming on strong lately. They have some really, really good printers. Can't go wrong there either. So we're going to just keep going and going and going. Quick. So on this screen, at this point in the talk, we kind of narrowed it down to FDM printing. We've said to use PLA as a start. The next thing is, where do you find things to print? If you don't want to go spend a year learning Fusion 360, you can just get things to print automatically done for you, already done. And here's a couple of sites that you can go to. One of the most popular one is Thingiverse, been around since like 2008. They have everything under the sun there to print. And when I saw the minigun, I just thought, okay, I've got to have it, right? I would love to print that. That looks super fun. But on the right, something slightly more useful. This is on printables.com. And this guy, NGC6543, might be on the call today, not sure. But he does a lot of these kinds of things, very useful, that you can go grab those. And when you download them, chances are it will be an STL file that you have to then slice. And so what the heck is slicing? We'll talk about that real quick. There's another site for you, Tinkercad. That's where you can actually build your basic shape. So if you want to design something that's kind of simple and basic, you can go to Tinkercad and
yeah, Dave,
on your own. Yep, sorry.
Yeah, if I could just jump in really quickly. So Tinkercad, I saw a question posted in the chat about some other free CADs, but Tinkercad is probably one of the easiest SaaS-based solutions to use. When you download an STL, you try it out, it maybe just isn't quite right, you can upload it to Tinkercad, make some tweaks to it. It's not like plug and play, but it's really simple to do. In an hour, you could be a decent Tinkercadder if you just follow some simple YouTube videos. And I think we add some links to this, to our PowerPoint here, the presentation. So when people watch this later.
Yes, we do. We have that at the end. Okay, so that's some resources for you to go and download things. So you got Thingiverse, printables, and then here's Tinkercad for you. And so I mentioned slicing earlier. We talked about slicing. This is a extremely important part of 3D printing. And when I bought my printer, I had no idea that I had to slice anything. So I had to figure this out very quickly. And so basically what slicing does is it turns that model, that STL file, into G codes that a 3D printer can understand. So what the heck is a G code? You don't have to know G code at all. This is not something you need to know. I just threw that in there so you can kind of know this is how the 3D printer is telling itself what to do. So go to the X layer at 247, go to the Y layer to 11, move at a speed of 400 millimeters per second, and then that's what it does. But to get it sliced, what you do is you download your STL file, you import it into a slicing program. And a lot of the manufacturers have their own. So like Prusa has their own, Bambu Lab has their own. I chose to go with Cura, mostly because it's free and it's a really fairly straightforward one to use. And I found that for the most part, it has presets for all of the popular models of 3D printers that you would find. So what you do is you import this into your slicing tool, and then over on the right, you can kind of see where you can change some of the settings. So we were talking earlier about PLA. PLA has, the different manufacturers have different requirements for the temperature at which they would print. Some of the materials that you print require you have a heated bed. That's one of the upgrades that you should definitely get on your 3D printer is a heated bed. And so you have to have a heated bed at a certain temperature in order for it to print correctly and stick to the first layer. But all of that can be done in the slicer. So you bring it in here, you do your settings on the right, and then you save that to a file that contains the G code. And then from there, you can push it to your printer and print. So at that point, we've talked about, getting a FDM printer. We've said use PLA. You have to get a slicer. And so Cura is a good slicer to use. So if you don't, well, let's go to this screen right here and we'll go back. So where are we at in this call? If you're sitting there saying, hey, I'm new, I want to get into 3D printing, I don't know where to start. We've kind of picked a few different printers here that would be really good choices depending on where you want to get in, how much you want to spend. That one on the right, the Bambu Lab Mini 3D printer is super cheap, but it's also super simple. It's got the features we talked about earlier of kind of the low-end printer, but it's a very good low-end printer. The Ender 3 V3, that's just the newer version of the one that almost all of us have here on the call. So I figured it's got to be a pretty good one. So it's going to have, a lot of the good features for a mid-level printer. You can't go wrong with that one if you were to get that one to start with. And then on the left, that's the Bambu Lab A1 3D. That's got a lot of the extra features. You can do the add-on there to get 4 different colors. And so that's very upgradable printer. Bambu Lab is great. So that would be if you're entry level and want to spend a lot of money, you could go that way and be fine. So really quick, I think to finish up, if you want to do 3D printing and don't want to do any of this stuff, you can just download the STL files from Thingiverse or Printables, and then go to some of these online services that can print it for you. The one I will highlight here is CraftCloud. That's the one I use. That's my personal choice. So when I got my stuff printed in SLS, I went there, uploaded my STL, and then picked a SLS format and got it printed and mailed right to me. But there's other ones like QuickParts, Xometry.com, and then Hubs.com with Protolabs. All offer the same kind of services. And then finally, here's a whole bunch of YouTube videos that talk about every single thing that we talked about today. So if you want to dig in and learn more, here's a whole bunch of resources for you to follow. And finally, thank you. That is our talk for today. I don't know if we have time for Q&A. I don't know if there's another session at 1, but if there's not,
there is another session, but we can hang out and field questions if we need to. And let me see if I can make it where everyone can speak here.
Yeah, I was gonna say, love some Q&A.
And Spencer and Colin, thank you very much for participating. You guys are clearly experienced 3D printers. Jim, you too.
Sorry for being so long-winded earlier.
Man, it's hard not to.
Oh, good.
You just needed to stop me there, Dave.
Yeah, I think one of the things that you kind of touched on, Tom, is worth rehashing. You have to be okay with embracing failure if you're going to get into 3D printing. It's going to be inevitable. So if you're buying one of these for your kid and you want to give it to them as a Christmas present, I would advise you to get the more expensive ones that are a little less prone to failure. That way you don't spend as much time babysitting stuff trying to get it to adhere for the very first time.
So is it open for everybody to talk?
Yep, everyone can talk now.
For it.
I'm gonna say I had an SLA as my first one, the Mars Elegoo Pro 2, I think.
Mhm.
And man, super messy. Dude, if you ever spill some of that stuff,
Oh,
don't think
Lord.
you can just kind of use a UV light to kind of harden it up and then chip it away. Yeah, that doesn't work well at all.
Yeah, and every tool you use will eventually feel slimy and just weird. Yeah.
So Dave, what are you technically supposed to do with the alcohol bath after you get done cleaning?
So I've heard, I won't tell you what I did with it.
Yeah, I won't tell you what I do either. I just wondered what I never thought about where do you dispose of it?
Well, so
Environmentally studious.
yeah, so I know a lot of people will just like set it out in the sun and let the resin that's in there harden, and then they can
Oh, I
filter
never
it
thought of
out.
doing that.
Yep.
And then they can reuse the alcohol, or, because it's now kind of a toxic substance, you can take it to like the same place you would take paint to, your local disposal area.
Yeah,
but
well,
I know,
I currently take mine to the same place I take my paint to.
yeah, same here.
Also
Absolutely.
evaporates really well.
Yeah, just sit it out in the sun and let it evaporate.
Yeah, I never thought about trying to precipitate the resin out of the alcohol.
Yeah, just let it settle to the bottom and then take it outside and it'll harden and then you can just chuck it in the trash.
There you go. All right, any other questions? So with that, I guess we can end. Don't forget to be there. Half the people have already checked out of this session, but don't forget to be there tomorrow night at the closing session to see who wins the Bamboo Lab. I think it's a Bamboo Lab printer. It's a really, really good one. Congratulations to whoever wins
Whoever
that thing.
wins.
I'm
Yes.
jealous.
Yeah, same.
Yeah, those are super nice.
I have the P1P myself. I love it.
I think that's what Randall has.
And yes, Jason, get your Ender 3 out. It's fun. And
Yep.
everything you just said, you got it as a gift and it's been sitting in the basement. He said it's time to use it. I would agree.
Yeah,
Get it
one of
out,
the
give it a
cool things
whirl.
with those Ender 3s, Tom, worth mentioning is you can get larger frame kits for them
Yes,
and
you
then
can.
expand them out pretty substantially. That's what one of my 2 is.
Yeah, Robin, I
500
was
millimeters on
saying,
the side.
Dave and I were talking about this earlier. I think at this point, outside of the frame, that might be about the only thing that's left of the original at this point. So
Yeah, using your
Great to
3D
mod.
printer to upgrade your 3D printer is awesome. It's
yes, that is true. It's perception.
very satisfying.
Yes.
Sitting here looking at mine, and I have to agree with you, Tom.
Yeah, it's but they just turn into a shell. You fix one thing and it just turns into a completely different printer at some point.
I would like to have the dual Z, but
Yeah.
I just haven't done that yet.
Very cool. All right.
Putting the second Z motor on.
Yeah, gotcha.
Thanks a lot, guys.
Yeah,
Thanks,
certainly.
everybody.
Thanks for
Appreciate
everyone's
it.
interactions. Yep.
Catch
Thank
y'all
you.
in the next session.
Thank you all.
Bye now.